Okay, people of geometry, here we go. Circles in the coordinate plane. We already know what a circle is, defined by its center point and its radius. We know what a coordinate plane is, as the XY graph. X axis, Y axis, coordinate pairs, unique points, all that good stuff that you remember from algebra and everything I've taught you. This is page 527 in your workbooks if you want to follow along. I recommend when you're done with this page, keep going, but we'll get to that later. So right here, I'm going to go through this quickly. You see here on the right, the circle. It's at center C, which is point HK. That's the center point, HK, always. And you see this radius here, the distance from the center point to the point on the circle. That's called the radius, okay? Well, we're going to define some point P on the circle at coordinate XY. That's just general. We don't know. It could be any. It could be this point. It could be this point. It could be this point. Doesn't matter. Create a right triangle by drawing a horizontal line through C. Follow directions. A horizontal line through C. Right? A vertical line through P. Okay? Those intersect at point A. What are those coordinates? Well, we know that this is what? And what is this coordinate? Well, this y coordinate is k, and this x coordinate is x. Right? This goes up k, you can tell from our yellow line here at point C, and it goes over x. So our coordinate here is xk. So what are the expressions? Well, by now you guys are smart. You've already seen them up here. Remember that the distance, just like we've talked about many, many times, if this whole distance right here is x, well, what's this distance? I need to subtract out this distance, right? Which we know is h. Therefore, this horizontal distance right here must be x minus h. Similarly, this vertical distance must be y minus k, because the whole distance is y, and we subtract out this k part right here. So those are the expressions for the lengths of the legs. Notice we now have a triangle. We now have a triangle whose leg lengths are this, which is what this expression says. Oh, I gotta let the dog out. I'm so sorry. While I do this, maybe you should figure out the Pythagorean theorem for this triangle. What is it? What do you got? Yeah. All right, back to our regularly scheduled program. Well, a squared plus b squared equals c squared, where a and b are the legs, so x minus h and y minus k. And the hypotenuse is opposite the right angle, which is r. That equation that you see is ridiculously important. That is the general equation of a circle in an xy plane at center HK with radius r. Notice it's a difference. Very, very important. Subtracting here. That's going to make a big difference when your coordinates are negative. So this is pretty obvious. We already did this. I'm just going to keep going. Right? If the center is HK, the x goes with the h. and the y goes with the k. So you just plug those in and square those puppies. And then the r must be squared. Okay, that's the general form of an equation. Write it down. Put it on Sharpie on your face so when you look in the mirror you see it. I don't know what to tell you. What about a circle that has the center at the origin? Well, if that right there is 0, 0, what happens to the h and the k? Well, they become 0. When 0 is there, it's all gone. Whoop, 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 whoop. Yeah, it's tough times, people. X squared plus y squared equals r squared. That's the form of a circle centered at the origin. Okay? Here you see again the equation of the circle. Center HK, radius r. We just did this. If the coordinate is negative, notice negative parenthesis negative turns into a positive. Very important. When you see that as a sum, you know that the coordinate is negative. So let's just work through this quickly. Center 2, -1. Radius 6. That means I'm going to have x minus 2, y plus 1, as evidenced right there. Protect yourself with your parentheses. And 6 gets squared. And here you have the final answer. This part's pretty easy. Down here, remember the distance formula. Right? Here you've got an equation that's got no picture. Up here, they give you a picture. Here, all they tell you is the center point, which is easy. We're going to need that later. And we know that it passes through a point. Well, that means we need to find the distance to determine what that radius is. So that's why they use the distance formula here between these 2 points. Remember, the order doesn't matter because when it gets squared, that negative number is going to get squared and become positive. Once you determine the radius is 2, you then use the equation of the circle, plug in your answers, square your radius, and get your final answer. Pretty simple. I'm going to do a couple examples here. So take a look at this question. Where is this centered? -1, -1. What's my radius? 1, 2, 3. Therefore, I know I have x minus a -1 squared plus y minus a -1 squared, 3 squared. Well, what does that equal? That's all x plus 1 squared plus y plus 1 squared is equal to 9. That's the answer for this one. Okay? You try number 2. I'm going to push pause. No. God, what is wrong with me? You push pause and see if you can figure this out. Where's the center? What's the radius? Plug it in. Boop. All right. Well, we know the center is at 3, -1, and the radius is 4. Always use the horizontal and vertical lines to determine the radius. Just count the blocks. Therefore, we just plug in. That should be your answer. How about over here? Well, we know we have x. The x coordinate goes with 4, so that's going to be -4 squared plus y minus 5 squared is equal to 8 squared, which is 64. Simple. How would you do this one over here? Well, it passes through 3, 6. Oh, I guess I should teach you how to do this one. All right, it passes through 3, 6 and has center, so you have to work out the distance formula, which is going to be 3 minus 2 squared plus 6 minus 6 squared. Well, that's 0. This is 3 plus 2, which is 5 squared, which is 25, which is equal to 5. So we know the radius is 5, which leads to our end of our equation being 25. And here the center is -2, so this becomes a +2, and 6. That's how you should do that. All right, I'm going to try and finish up here. You can also use this equation by making a table and identifying the center and radius separately. So much, plug in an x, get a y, stuff like that. This is pretty straightforward. Like right here, you're going to see what's the center of this equation. Well, the x coordinate is 1. The y coordinate has to be a -4. And the square root of 9 is 3. So you can get information from the equation as well. Real quick, this is centered at 1, 2, which is right there, with a radius of 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3. Circle it up. How about this one over here? This has to be a -2, +2. Square root of 9 is 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Something like that. So this would be 1, 2 is the center. Radius 3. This is comma -2, 2. Radius 3. You try these two. Boop. Well, what's the center? 3 and -1. Square root of 4 is 2. When you graph those puppies, whammo. How about here? -1, oh, duh. What a butthead. That's it. Let me know if you have questions. Be safe. More to come.